Great. So let's get started, and I have to be on the right machine here. This talk is about the future of Visual C++ and Microsoft's commitment to this product. And I'm excited about this product because this is the most powerful language for creating applications, regardless of what platform you're building for with C++. C++ has traditionally been the preferred language for creating the best applications for all multitudes of platforms. What I'm going to show you today and convince you of is that C++ going forward is going to be a serious development language for developing applications on Microsoft.net. And that Microsoft is fully behind this language, and that we're super excited about the fact that you can use C++ to get the most power and performance and control out of the applications that you're building. Leading into this, we're very excited because recently, this April, the 2001 IDC Professional Developer Model reported that worldwide there are 7.8 million professional developers, and 34% of those developers, roughly 3 million developers, are C++ developers. Yeah! In North America alone, there are well over 1 million professional C++ developers, and the trend for these developers is only increasing. We're seeing more and more C++ developers every day. And this is just, great because C++ has a tremendous following in the past, and going forward, it's going to be a great language for developing applications. Also, we know that at this conference, we've got the strongest following of all the developer classes because we have the best T-shirt. How many of you got one of our T-shirts? Put your hands together. All right. We didn't have enough, apparently. You saw the back, right? Everybody saw that it's, here's a pointer. Real programmers use C++. I thought I would set the stage for this talk in setting the stage for our future plans for C++ by very quickly recapping what is just around the corner with Visual C++ 7.0. With C++ 7.0, we're delivering a very capable, the most advanced compiler ever out of Microsoft. We've got a lot of great enhancements, not only for the native or unmanaged developer, which is what we've all been doing traditionally, the normal C++ development, but we've also got a great load of enhancements for the managed development side as well. For the unmanaged developer, we've done some great things with our compiler. Where would C++ be without the compiler? So we've got things like whole program optimization, which enable you to have the compiler and the linker work hand in hand to create a more efficient executable. We've got great language enhancements, things like attributes, that enable us as C++ developers to write more robust code with fewer lines of code. We don't have to write all of that boilerplate code for ATL that we had to write before. We've also done great things like refining ATL and MFC so that they work better with each other. And we've revamped STL so that now when you debug into it, you don't have to decipher all those one-letter variable names anymore. Yeah! And we delivered ATL Server, which is a great way to create unmanaged XML web services that are fully SOAP compliant and can plug and play with all of the web service technology built into Microsoft.net. These are just great new things in Visual C++ for the unmanaged developer that will enable you to create the next generation of application software running on Microsoft Windows and Microsoft.net. For the .NET developer with C++, we've done a lot of work here to make this the most enjoyable experience for creating .NET applications. We made a very, very powerful feature available to you called It Just Works. This is the ability for the compiler to take your existing code without making any changes and throw a compiler switch and have it generate MSIL. And just for all of those of you who weren't aware, of course, we're applying all of our optimization technology from our native compiler on this MSIL to create the best MSIL for .NET applications. Of course, with .NET applications, you also have the ability to access and consume all of the different services and features of the .NET framework. You can very simply, with C++, just start creating and instantiating and accessing all of those great classes that are exposed through the framework. Things like regular expressions, things like the Windows Forms technology. It's all available to the C++ developer very easily. We've also gone through great lengths to expose through C++ all of the low-level features of the platform. And in fact, this is one of the key directions that we're taking the product, making C++ the low-level systems programming language for Microsoft.NET. And you're only going to see more and more of this. We'll talk about this later in the talk. And then finally, with Visual C++ 7.0, we're delivering the best-in-class interoperability support so that you can take your existing code base and move it forward into .NET very easily without having to go through a lot of hoops. This is just going to be providing a great number of convenience features for C++ developers going forward with Microsoft.NET and Visual C++.NET. We're extremely excited. I said that we're just getting into our planning phase for Visual C++, the next generation product. And I am very pleased to announce that this week, Microsoft hired Stanley Lippman, who is a C++ pioneer. I'm sure you all are aware of the name. Stanley, I'd like you to come up on stage with me. How many people learned C++ from Stanley's C++ primer? Yes, this man standing next to me, I know I pale in comparison, is going to be a great asset to the Microsoft development team. He's been hired on as an architect for C++, for Visual C++, and I just want to give him a chance to talk to you a little bit about what he's going to bring to Microsoft Visual C++.
Thank you. This is a semi-Microsoft talk. It's probably more what you would get at a Usenix conference, so I'm not quite exactly immersed in the culture yet. For for 7 years, I've actually gone Hollywood. I'm one of the few people that are not hopping on an airplane to leave wonderful Los Angeles. The weather is grand. I'm going to use this as a sort of introduction to my experience of .NET. I was on Fantasia 2000, and I was called a software technical director. And one of the side effects, or the interesting side effects of being on a production is I was on the union. I was in the union. So I'm actually a card-carrying member of the Screen Cartoonist Union. And one of the interesting things, and one of the highlights of my career in software, and my management doesn't know this yet, is that when you're a union member, if you work over 8 hours a day, if you work over 40 hours a week, if you have to come in on Saturday or Sunday, you get paid overtime. In fact, Sunday is double time. So one of the interesting experiences I had working on Fantasia was my management would actually peek in my office and say, "Go home." And so I'm not sure yet. We haven't really discussed it, but I'm presuming that Microsoft sort of has the same kind of I don't know yet. It's too soon to tell, but I'll let you know. Any case, one of the things that I did, actually it started out surreptitiously because I was working in the core technology group of Disney. And to be honest, it was a lot like working for a shoe store in a lot of ways. You were off in the corner. Nobody was allowed to see you. And only when they gave you the T-shirts and the free videos did you really remember you were working on the movies. And I really desperately wanted to work on a movie. So a friend of mine was what's called a CGI supervisor, computer graphics imagery supervisor. And he said, I'm lead on this segment of Fantasia. Would you like to work on it? And I said, sure. And he said, well, but, I'm afraid you might be bored. Because it's different kind of software. So he said, we'd like you to sort of audition. And the way the Firebird segment, the way it works is, and the way a lot of the cartoons work is, they draw the a lot of the characters, and then they do CGI elements. So for the Firebird, one of the main characters is this wise elk. And the elk is drawn just like out of Bambi. They actually did their research sort of looking at Bambi. And, but the antlers were actually very complicated. And because of the way the elk moved its head, they wanted to do the antlers on using a product called Alias, which is also Maya now. And the problem is that here you have the antlers over here on the computer, and you have the other guy, the elk, drawn on pieces of paper. So somehow we had to match them up and animate them. And my supervisor had this interesting idea. There's a thing called the Disney camera. And what the Disney camera does is it, basically locates the animation on the screen. And what we had to do in order to lock up the antlers and the elk was he had the idea of capturing all the Disney camera information, which is just streams and streams of information, capturing it and then generating what are called Bezier curves. You may know Bezier curves from one of the screensavers on your NT. And now XP, I'm sure, has evolved past Bezier curves. Animation basically works as you have a beginning location and an end location, and then you want to basically automate the animation. And in order to make it smooth, you need to use what are called Kubik's curves, which are Bezier curves. This is all, I'm sure this is why you came to the talk. I had no clue what that meant, but I had to basically capture all the information and generate the code. And I did it in C++ because that's what I know. And it was surreptitious because it was going to be a coup if I could do it, and they decided they liked me. I had all this management people that were going to tear me out of core technology. So it was important to me, and I was doing it, and I was using the string class to do it because it had just come out. This was a number of years ago. And I found that, I got it done, and I got the job, and everything was happiness. But it was really hard to do. It took like thousands of lines of code because all the regular expression matching I had to do using the find first of, find last of, compare, and all those silly things that you have to do in the string library. It was very powerful, but it was very tedious in a way. And then I found out, as soon as I got on, and I don't know what Microsoft has in mind for me, but as soon as I got on Fantasia, they told me that, oh, I'm glad you did it in C++, but you can't use C++. It's too complicated because animators use the thing, and they said you have to rewrite it in Perl. So, I said, oh, okay. And so I got a book, and and it's the kind of just-in-time learning kind of thing. And one of the things that I really loved about it is that Perl supports really first-class regular expressions. And so basically I took thousands of lines of find first of, find last of, do the pulling out the substring, and then translating it into arithmetic values to do the arithmetic. I found I could do that on one line. It was a very complicated line. And to be honest, after a week, I wasn't quite sure if I remembered what that line did. And after a month, I was really impressed with whoever wrote that code. But, it worked. To tell you a secret, I had a coach, and the coach said, you're very New York and very Woody Allen, and it's not going to go over. So I'm glad to know that there's a little New York in all of us. So in any case, when I started working with .NET, one of the things I do when I go to a new language or a new platform is I try to do something that I know how to do. I have to do two things with the platform if I'm going to use it. One is I have to be able to do something that I could do previously at least as easily, if not better. Because if I can't do that, why bother changing? And then the other thing I have to do is I have to do something that I can't do in my other platform, or why bother changing, because I'm comfortable in it. So I decided I was going to take my Disney camera work, and I was going to translate it into .NET, because they claim that they have a regular expression library as one of the namespaces of the framework. So I was actually astounded to find that I could write a first-class language and actually get all the regular expression support, except for the grouping syntax, which is a little strange to me, that I had in Perl. So I could still write this amazingly impressive regular expressions that I always have to like study to remember what they're doing. And it worked. And I was really impressed because I had found the power of Perl, which is a very volatile and easily broken language, in a high-level object-oriented framework. So for me, that was a really important step. The other step I had is what you do as a software TD is anything. So, for example, I wrote this command line thing to do the camera, and of course, who wants to write, invoke a command line? It's like DOS, right? So I had to write a window. I mean, it didn't have to be a fancy window, but I had to have something that they could write the name of the file in and do that kind of stuff. And so I used Tickle. Now, I don't know if many of you know Tickle, but Tickle is a fast way of writing GUIs, and it's the kind of thing where what you do is you write the thing down, you have a canvas and locate it, and then you wonder if it's going to look right, and you do it, and then you go back, and then you do it, et cetera, et cetera. So again, when I found ASP.NET, and I could actually, what did I add? Oh, and then, so I did I got completely confused here, excuse me. So I have the window forms. I found the window forms really cool. Just like Tickle, they're not good enough in the sense that if you're doing really complex windowing applications, you're going to end up hitting barriers. But if you need to get something done really quick, it's really quick. I mean, I know all the Visual Basic programmers knew that, but I didn't know that. Okay? So I was really happy. The other thing I did is I did Fantasia web pages. And the way I did them is I had a VI window over here. This is Unix. And I had Netscape over there. And I'd write my HTML. And then I would hit refresh. And I would see what I had in Netscape. So, again, I found ASP.NET just nice. Okay? So I basically really liked .NET. I had a choice. I could either have come here, or I could have gone and worked on the Mars rover for the Jet Propulsion Laboratory. And although on one level the Mars rover is more interesting, the problem with the Mars rover is this huge specialization to avoid rocks. And it's a robot, but the only thing the robot does is avoid rocks. I said, well, what happens if you find a lake? And that was it. The rover would be useless. And my other experience is I was working at DreamWorks. And let me tell you, working for DreamWorks is like my leaving Microsoft to go to Sun. It's not a friendly relationship. So, and DreamWorks has decided, because SGI is not really a viable platform anymore, to move to Linux. Now, I've been working at Bell Labs and Unix for a long time. And I found it was like deja vu all over again. I felt like I was back in 1984, personally. So to me, .NET and Windows is the most interesting technology, and the framework that you get in .NET is one of the nicest things. To me, it's Unix. I mean, that's the way internally I explain it. So to me, .NET is the most interesting technology out there right now. And Windows is the most interesting platform to work on, and that's why I'm here. But the funny thing is, I didn't come to Microsoft to work on C++. I don't know about you, but when I look at .NET, I don't see C++ blazoned in 3 dynamic power, control, and performance. I just don't see that. I see C#. So I really thought, well, I guess C++ is just, Microsoft doesn't care. And so, I went to my first interview and I met a C# guy, because I wrote a C# primer. That's my commercial. I'm sorry. To be published in Don Box's Developmentor series. I'm sorry. I didn't say that. Okay. So I didn't plan to work on C++. I thought, oh, well, web services are cool. C#'s okay. And it turned out after I met with the first C# person who said, well, I assume you want to work on C++. And I said, well, I want to work at Microsoft. And I then met a succeeding number of people on the C++ team, and I was really amazed that they actually had a firm commitment to C++. More than a firm commitment, they were actually enthusiastic. And they got me enthusiastic because I didn't think I really had much influence left or opportunity to work in C++ since I left Bell Labs. And so to me, this is actually very exciting. I didn't know that I could work in .NET and also work in C++. C++ has always been about choices. A lot of you probably curse Bjorn for giving you so many choices. Well, you don't just get everything being a virtual function. You have to decide. If you don't like the virtual mechanism, you can make it static. If you don't like the template mechanism, you can specialize it. If you don't like casts, if you don't like the type system, rather, we'll just go down to the raw machine. We've always wanted to do that. And because nothing is ever quite exactly what you need to do. You can always get 90%, if not 80%, on the general stuff, but getting to the real finished product is hard. So the way I like to think of managed C++ is, in a sense, it gives you the best of both worlds. It allows you to go back and forth between the unmanaged world when you need that and the managed world. Now, it isn't like C# didn't realize that they need something, and they have their quote-unquote unsafe code, which is really C pointers, and that allows them to bit blast bunches of memory either from a file or doing some kind of blitting. But that's really, who wants to go back to writing C pointers and just doing bit blast? I'd rather have a full language. So our goal in managed C++ is really to create the tradition of C++, which is to give you anything you need. We're not philosophy. Because as Herman Melville once wrote in a book, life breaks in on philosophy like morning, which is one of my favorite quotes. But freedom requires responsibility. I have this long thing about collision detection, which I can't talk about too much because I really have to get off the stage and let Nick drill down into some real details. But I believe when people talk about C++ and ask questions about C++, they're asking the wrong question. And I can actually spin this example out for like 50 minutes, but I won't. But people always say, in computer graphics, collision detection is a major thing. If you're doing Mario Kart, you have to know when you hit the truck and your cart goes off the thing. And so the question isn't do you do collision detection, the question is how much effort do you put in it, what's the priorities? And in a sense, that's the way you should think about managed C++ in this first edition. For Mario Kart, the key ingredient is speed. What you need to do is you have to get those carts running fast. So they don't get really good collision detection. You have to go halfway into the truck and have Mario's head half immersed in the truck before they figure it out. Now, on one hand, that's stupid. From a computer science point of view, that's dumb. But from the game point of view, actually, the kids like it. And it keeps the speed. And that's all that really matters, because that's what the point of it is. It's not philosophy. It's getting it on a platform and delivering to your users. Similarly, with the Hunchback of Notre Dame, if you saw Pocahontas, and she's rowing onto the beach, I'm sure I've seen Pocahontas like 47 times, so I'm sure all of you have. But in any case, when she gets on the beach, the Indians that are closest to her are moving. It's a group of Indians, and they're going like this, and they're going like that. And as soon as she walks past them, they actually stop, and they're just a painting. And then the middle group of people are moving, and then when she walks past them, they stop, because it's very labor-intensive to do crowds in animation. It costs a lot. In fact, if you look at the Flintstones, all they do is move their eyes and their feet because movement is expensive. So they decided to use C++ and to get crowds in Notre Dame. And they created 4 characters, and they just put different hats and clothes and all this stuff on them. And they had cycles. So one of the cycles was a lady that goes like this. And the problem with going like this is if somebody's face is over here, you really can't have it go through the face because it ruins the level of reality that they need. So they have to do the collision detection soon enough to stop the hand from slamming through, because it just goes through. But all they had to do was do what's called a bounding box, which is a very coarse-grained catching of it. You just catch that the hand's about to go through, and you stop it. And that's not hard. The Tin Soldier, if you saw in Fantasia, actually took over 2 years. It was only 8 minutes, but it took over 2 years, and we had to hire a PhD professor from Toronto University who understood particle physics. Because what we wanted is we wanted the cloth of her dress to go up and down the correct way. But separately, we were animating the figure. And so when her knee went through the dress, it spoiled all the and it was actually hard to get the two. It was the same problem as the antlers and the this is a quiz. What is it? It was the elk. Thank you. So the point is, again, when you see Visual Studio 7, you don't say, oh, what happened? Is it managed? What's wrong with managed C++? Why isn't it there? Well, we did what we felt was the most important, which means you have a legacy of C code, C++ code, that you need to use. And the best way, or the simplest way of getting it into C++net is to write managed extensions around it. But we want to push the language further. We want to get first-class templates for the people that are writing unmanaged code, and we want to make C++ a first-class net language. And we're committed to that, or I wouldn't have joined the company, because I'm leaving the sunshine. Okay? So it's deja vu all over again to me. I feel like I'm back at Bell Labs, to be honest. This is the closest I've been to being with language developers, to being back with C++, and being with what I think is exciting technology. And what Nick is going to do now is he's going to drill down and actually give you the details. Thank you.
I knew I'd be upstage. What I'd like to do now is spend the remainder of the talk and drill down into some of the vision and functionality that our team has started to develop for the next generation of the Visual C++ product. The first thing that is key on our list is enabling C++ as the systems programming language for .NET. Historically, C++ has always been the language that exposes the key functionality and the low-level bits of whatever platform it is targeting. And we feel that this is what C++'s mission is for .NET as well. We're committed to enabling through C++ all of the different things that .NET does at a very low level and giving you the ability to twist and turn those knobs through C++. We also wanted to enable all of the different scenarios for building applications through C++. In the first edition of the .NET product with C++, Visual C++ .NET, we really focused, as Stan said, on providing the best interoperability and best code generation on the platform, because we knew that developers such as yourselves had large sets of code that they needed to bring forward and enable on Microsoft.NET. Going forward, it's our intention to also enable, as a first-class feature of the language, the ability to create new components and new applications using C++ on .NET. You can do that today. We're going to make it better tomorrow. I already stated that we have the best interop. This is one of our primary missions with C++, to have the most efficient interop and the easiest to use interop, so that you can use your existing native code or your existing C++ code directly from C++. Going forward, we're just going to make that better. The same with CodeGen. The C++ team has a lot of pride in having the the most world-class code generator on the planet. We are able to create the best 386 instruction set code, and we're going to apply that technology and knowledge to creating the best MSIL code for .NET. It's very important for us to do all of this while retaining the full flavor of the C++ language and the syntax and the constructs that comprise the language. There are a lot of different power features in the language, such as templates that, as Stan said, we're going to enable in C++ going forward for managed code. We think that this is going to provide extremely powerful features that you won't get anywhere else. Also, we think that another key aspect of C++ are the libraries that you use. Not just the libraries that come from Microsoft like MFC and ATL, but some other libraries like STL and Boost and Blitz and Puma. These are new libraries that people are starting to use extensively across their applications, and we feel that in order to augment the C++ developers' experience with the .NET framework, they will want to be able to use and leverage these libraries that they're already building applications with today in a managed environment. To achieve this vision, what we've done is we've started to break down all of the different features that we need to implement to achieve the vision. There are a number of them. I'm going to list out a few of the ones that are key on our list today. The first is the multiple programming paradigms aspect of C++. I'm going to dive into this in a moment, but basically the fact that C++ has always been able to adapt to the different programming paradigms and patterns that we use in our application development. Verifiability. We want to be able to give the C++ developer the capability to, you could always shoot yourself in the foot, but now we want to enable the C++ developer to declare to the world that, hey, I didn't shoot myself in the foot, and you can verify that I'm not doing that. Designer and IDE support. This is probably one of the most visible things that you'll encounter that is missing from the C++ 7.0 compiler today. You start up Visual Studio and you notice that you can create a WinForm or web form application with C# or Visual Basic, and that you can't do that with C++. Well, of course, you can create those applications. We just don't have the designer support, and so we're very committed to delivering these features down the road. Optimizations. We've done a lot of work with our 64-bit compiler. I don't know if you're aware, but with the release of Windows XP this week, we simultaneously released the 64-bit version for the Itanium. C++ is the only compiler that enables you to develop applications on that platform today, and we've done a lot of work to make sure that you can create the most advanced applications using advanced techniques that are really required by the Itanium instruction set to make efficient applications over there. We're going to move some of those technologies that we've learned and implemented on 64-bit back into the 32-bit environment. I'll talk about what those are. Libraries. What would C++ be without library support? Of course, MFC and ATL are extremely robust libraries for creating thick client applications on Windows today. Our intent with MFC and ATL going forward is to always keep these libraries in parity with the operating system, giving you wrappers for all of the newest features of the operating system. And we intend to keep up with this going forward with Visual C++. And then finally, a big one that's on my list. Okay, clap now. I'm going to talk about it later. Microsoft is extremely committed to ANSI and ISO conformance for the language, and there are a number of different reasons for this that we can get into. One of the powerful aspects of C++ is that it has always been able to keep up with the different programming paradigms and models that C++ developers have devised. It really started back with Smalltalk, free C++, where we had developers creating libraries and classes that were really not type safe. But then with the advent of C++, we were able to introduce those same concepts into the C++ language and create the same type of class libraries. But then because C++ is a type-safe language. It's a strongly typed language. We were able to do even more. We were able to create complex class hierarchies like MFC, where we introduced complex object models in a type-safe manner. And then enter the component-based programming model, where we introduced COM and we introduced interfaces to our class hierarchies that we were building. This is a very powerful construct in terms of the fact that we were able to separate the contract of our objects from the implementation of the objects. And we could implement pluggable components. We could do things like in ATL and the .NET framework are good examples of this component-based model and programming paradigm that we were able to do in C++. Moving forward, we started writing generic programs with generic algorithms and generic containers. Things like STL enabled us to create containers that could hold any type of object, but in a very efficient manner. Or we could create algorithms that worked on different types in a very efficient manner, all done at compile time. These are just aspects that show how C++ was able to adapt by just providing complex and powerful language features like templates through the language, but then providing support for these different styles of programming. Moving forward to generative programming, we see these newer libraries like Blitz and Boost and Puma, which are creating these compile-time code generation algorithms that are really that much better than what we had with generics. We're now able to create at compile time and specify for the compiler the algorithms that we want to generate in a very concise and efficient manner. And we can do this all through C++ through complex expression template support. All of this support has evolved with the language. It started out, years ago with C++, and then as the standard evolved, we added these templates and we added all of these things. And as we go forward, it's very important that Visual C++ is able to support things like expression templates. It doesn't today in Visual C++ 6.0, but certainly we're very keen on supporting this as we move into the future. And one of the really major reasons that this is important is because we see at Microsoft that with Managed C++, we're evolving again. We're introducing to the applications that we're developing new platform technologies like garbage collection. And now with the complex features of C++, we're able to take advantage of these other platform technologies in a very elegant manner. A good example of what really makes C++ a very powerful language for encapsulating these complex ideas really comes out when we talk about resource management. If we take, for example, in .NET, what we have is this garbage collector and this garbage collected heap for our resource management, and specifically for memory management, but also for the objects that we're creating ourselves. And so an example here might be that we have a file handle or something, and we need to be able to definitively know or have control of when that file handle is cleaned up. So to solve this in .NET, because it has a garbage collected environment and there's no way to have control over directly, stack-based or whatever, the lifetime of that object, we've added the support for iDisposable interface. And so to make iDisposable work really well in C#, what we did was we added a keyword to that language, a statement really, that made it easy for the programmer to use the iDisposable interface on their own objects. And then through that mechanism, you can control the lifetime of the object. But we've seen this before in C++, and we didn't have to use, we didn't have to wait for the language to provide, some built-in keyword to implement this. Instead, what we saw were things like auto pointers and templates. We were able to implement these design patterns because the language was powerful enough and gave us enough features to be able to express solutions to this type of problem. So in C++, simply, if we want to have deterministic finalization for a garbage collected object, we can simply wrap that object in a template class that, when its destructor is called, can automatically clean up and call the iDisposable interface. And so this is a really key feature and key aspect of Visual C++ and C++ the language, that we have all of this capability to, as the language paradigms evolve, to adapt and move forward with those. This is really just an example of what I just gave you. We could envision a different example where we want to be able to share our object with multiple clients. And instead of having deterministic finalization, we might instead want to have something like reference counting. And so again, if we were doing this in C# or Visual Basic or something like this, we might have to wait for the language to come along and provide a mechanism within the language specifically for implementing that pattern. But what we can do in C++ is simply create a new template and implement a new model or a new class that can implement that behavior. One of the key aspects that's going to be extremely important going forward on .NET is verifiability. And this is one of the things that we haven't given you or we haven't focused on in Visual C++ to this point in version 7.0. Looking forward, one of the things that we really want to focus on with Visual C++ the next generation is the ability to have verifiable code. What this really means is that we're generating code that is declaring that it will not be able to subvert the type system. What this means is that it's an example of this would be in C++, we can do all sorts of things like unsafe casts, where we can take one object and cast it into something that's completely different and not even related, and then manipulate the memory behind that. That's not something that's really intrinsically verifiable and really could cause problems. And so there are a lot of scenarios in .NET that require the fact for the code to declare that it is verifiable, and then indeed the CLR will run this verification process when the application is loaded. And this forms the foundation for the code-based security model on .NET. And there are a number of scenarios going forward where this is going to be important. So things like downloadable code. And so for Visual C++ .NET going forward, our intent is to enable the compiler to generate verifiable code and enable these scenarios for the Visual C++ developer. Of course, we also want to focus on things like the designer and the integrated development environment. I stated earlier that we're keenly aware that we don't have the WinForms designer or the Web Forms designer. These are things that we're very interested in implementing as we go forward. Another thing that's, of course, very popular, I think, from the C# language is the XML document comments. I got a lot of questions at the PDC this week. Can I do this in C++? Certainly, we're very anxious to develop this type of functionality and integrate it within Visual C++. One of the things that the C++ team is keenly focused on is always providing the tools and the tool set for creating the best applications possible. And we see this in Visual C++ 7.0 and indeed in earlier versions of the compiler, in all of the different efforts we've had for enabling different types of optimizations on your programs. In the 64-bit world, we've actually started creating and implementing a new style of optimization called Profile-Guided Optimizations, or POGO. And what POGO really enables us to do is create a new class of optimization. In the past, the compiler only had a limited view on what it could optimize. It could look at your source file and it could make guesses about how that code was going to be executed. What profile-guided optimizations enable us to do is generate data at runtime about the execution of our code as it exists in a real-world runtime environment, as the user's really using that application, and then feed that information back into the compiler so that it can generate more optimal code for that execution path. So the way that this works, and this works in 64-bit today, and we're looking at how we can enable this for 32-bit code and then later on for managed code as emitted by Visual C++, is what you do is you take your source code and you compile it with a compile switch that says instrument the code. And then when you run that instrumented executable, what it does is it generates some profile data. And what you do is you run the application and you use it as your end user would. You run it through the different scenarios that are going to be the common code paths used by a given user. And then you feed that profile data back into the compiler. You rebuild your application, and it rebuilds and creates a more optimal image file that will be, a much better application when you deploy it. So we're able to do a lot of really cool things with profile-guided optimizations. One of the key things here is that we're able to keep the common code that's executed over and over in the instruction cache of the computer itself. We're also able to do things like optimize for hot paths. So what this means is if you could envision that I have an if-else statement, and the common case was always the if aspect of it. So now, with profile-guided optimizations, the compiler can say, oh, well, it looks like in the 90% case, you're always going to be going through this code path. And we can optimize for that and then make the secondary case, slightly less optimal. We've achieved really great results with this. In our preliminary tests on 32-bit, we're actually obtaining a 10% performance increase just by invoking this profile-guided optimization. On Intel Itanium, the instruction set on that and the architecture of that chip is a lot different. And so profile-guided optimizations are a lot more important over there. And so that's where we focused our energy first for this technology. And we're actually seeing that applications that are profile-guided and optimized through this mechanism achieve a 30% performance boost. Now, you all clapped before because I talked about ANSI and ISO conformance. This is one of the great features that I'm really passionate about that I think a lot of you should be really excited about going forward. The reason for this is that there are a lot of great new language features that are really starting to become mature and robust and made available for C++ developers. And in fact, we're starting to see the proliferation of a number of advanced libraries for C++ developers that take advantage of all of these different features. So things like partial template specialization and partial ordering of templates. These are the two most common things that we've heard requests of over the last several years. And it turns out that we're in the lab today at Microsoft, we're actually building at a very high conformance level all of these different applications that make use of all of those different features. And so this is really exciting for us, and we've got this building in the lab, and we're very keen on getting this deliverable to you at some point in the near future. So what we're thinking about right now, and you can clap and tell me if you really want this, is how can we get this capability to you as fast as possible? Is this something that you guys want? Is this something that you've been clamoring for? All right. So what I'm not going to do is promise a release vehicle or a release date, but what we've been doing is we're very excited about getting these optimizations and these compliance measures into the compiler as soon as we can. And since we've got a lot of this working, we really want to push the bar and get as much working as we can. Our focus really is on getting these libraries that people are starting to use to compile. We're not just picking the low-hanging fruit off of this list that I showed earlier. What we're really doing is looking at the features that people want and implementing those and making sure that they work in a robust manner today for these libraries as they exist, but also we're working in conjunction with these library designers to kind of understand what the features are that they're going to be implementing in libraries such as this going forward. And so it's very important for us to make sure that our compiler is robust enough to be able to handle all of these scenarios as they evolve into the future. And so we're very committed and excited to be able to deliver these features finally after several years in the Visual C++ compiler. So I really wanted to conclude today by talking to you and saying that we're extremely excited to be able to deliver Visual C++. It's the power language for developing Windows and .NET applications today. Going forward, we're going to extend the language with the powerful language features like templates, enable them for managed extensions. You're going to be able to use your existing libraries like STL in a managed environment. We're going to enable conformance features, which will only enable these further. And then we're also going to always focused on our great code generation and optimization techniques that you know and love Visual C++ for.